Hi, this is Dr. Balairavan, Assistant Professor, Department of Mechanical Engineering, Kamaraj College of Engineering Technology. So today class we are going to see about the topic transverse loading in beams, shear force and bending moment diagrams. First of all, we should know about what is the meaning of beams. Beams is a structural machine member. It is a horizontal component carrying the load. Then there are three types of beam: cantilever beam, simply supported beam, and then overhanging beam. So these are the three types of beams. So now we are going to see about the construction of three types of the beam. First one, cantilever beam. So cantilever beam, it means that one end of the beams is fixed, other end is free. So this is the example for the cantilever beam. Then second one, simply supported beam. So simply supported beam means the beam is simply supported between the two ends. Two ends means two supports. The beam is simply supported between the two ends. It is known as simply supported beam. So this is the example for the simply supported beam. So many beam structures are like the simply supported beams. Then third one, overhanging beam. So overhanging beam, it means that the beam is extended beyond the two support. So two support mean the beam is extended either right hand support or left hand support, or the beam can extend both right hand and left hand support. So this is the overhanging beam. The beam is extended only right hand side. This is also double overhanging beam. The beam is extended beyond two sides of the supports. So this is also called as overhanging beam. So these are the three types of beams. So next, applications of beams in engineering. So beams is a main machine components carrying the load and transfer withstand the load of the machine members, as well as it is used in the construction field. The beams find widespread applications in construction engineering, aerospace, shipbuilding and automotive sectors. So these are the some examples of beams used in the construction sectors, as well as roofing, bridges. So these are the some engineering applications of beams. So beams having the different types of sections. Here I am mentioning I section and then T, inverted T section. So these are the some cross sections of the beams. Then shear force and its sign conventions. So shear force is nothing but it is the vertical force acting on the beam, the algebraic sum of the forces acting on the beam. So sign conventions of shear force. So there are two types of shear sign conventions. First one is the positive shear and second one is the negative shear. For simplifications, I mentioned some formula RUN. RUN means if beam is located right hand side, means the right hand side upward force is negative. Then RDP, right hand side downward force is positive. Then LUP, left hand side upward is positive. Then LDN, left hand side downward is negative. So these sign conventions based on our assumptions. If we are consider beam section is the left hand side or right hand side, based on our assumptions, we can use this sign conventions of shear force. Then bending moment and its sign conversion. So bending moment is nothing but it is the force into perpendicular distance, it is the moment. So bending moment means it is also algebraic sum of the moment of all the forces acting on any one side of the sections. It is known as the bending moment. The moment obtained by the forces on the left hand side of the beam is equal to right hand side of the beam. And then sign conventions, there are two types of bending moment sign convention. So first one is the positive bending moment and second one is the negative bending moment. So first one, positive bending moment. when the bending moment at a section is considered positive, when the beam is bending the top layer of the beam having the concavity, it is known as the positive bending moment. The positive bending moment is called as sagging bending moment. Second one, hogging bending moment. It is a negative bending moment when beam is bent, the top layer, the forming of convexity, that convexity forming in the top layer of the beam is known as the negative bending moment. So these are the two types of sign conventions of the bending moment. So positive bending moment as well as negative bending moment. Then types of support. There are few types of supports are there. So first one is the roller support. So here the roller is there, the beam is moving over the roller. Then pinned or hinged support. Here pinned or hinged support. Third one is the fixed support. So in fixed support, the beam is fixed at the one end or two end. In the fixed support, there is no movement of the beam. Other roller support and pinned support, the beam can move. Then types of load. There are three types of loads acting on the beam. First one is the point load. Point load or concentrated load. So point load means the load is acting at a particular point of the beam, particular point of any section of the beam. It is known as the point load. So in a beam there are n numbers of point load can act. Then uniformly distributed load. So uniformly distributed means the magnitude of load is same throughout the length of the beam. It is known as uniformly distributed load. So this is the uniformly distributed load. The another name of the uniformly distributed load is the rectangular form of load, because the load is uniformly distributed throughout the length of the beam. Then uniformly varying load. The uniformly varying load in the sense the load is varied point to point. The another name of the uniformly varying load is the triangular load. The load is varying point to point of the load, point to point in the beam. So this is the uniformly varying load. So here at A the magnitude of load is 0. At B the magnitude of load is maximum. So between A to B the load is varying minimum to maximum. So this is known as the uniformly varying load. So these are the three types of load acting on the beam. Then shear force and bending moment diagram. So here we are going to see how we are going to draw the shear force bending moment diagram for a particular beam. Then types of load, then shear force diagram and bending moment diagram. So first one, point load. In point load, for a shear force diagram we are going to draw the straight line. For a bending moment diagram, inclined line. For uniformly distributed load, for shear force we are going to draw the inclined line. For a bending moment diagram, it is a parabolic curve. Then for uniformly varying load, in shear force diagram we are going to draw the parabolic curve. For a bending moment, cubic curve. So these are the important one. You should remember this. So straight line, inclined line, this is the parabolic curve. Again for uniformly varying load, the shear force is a parabolic curve. For a bending moment, it is the cubic curve. Then types of beam, shear force and bending moment, sign conventions. This is also for your simplification. During solving of problems, these points are very, very important. So first one, for a cantilever beam, we are going to consider cantilever beam as a right hand side. So shear force always positive for a cantilever beam, bending moment always negative. For a simply supported beam, we are going to consider beam section is the left hand side. So the positive to negative, shear force is changing its sign from positive to negative. When shear force is 0, at that particular point bending moment is maximum. Then bending moment for a simply supported beam always positive. Again, overhanging beam, in overhanging beam both shear force and bending moment changing its sign. Shear force positive to negative, bending moment also changes its sign from positive to negative. The point at which the bending moment changes its signs, it is known as the point of contraflexure. So, these are the important points when we are solving the problems. Thank you.